Good evening. This is the video for the weeknight fairness and explainability on Irish datasets. And the objective of the weeknight is to add a static sensitive attribute location to the Irish dataset. Train a random forest classifier including location as a feature. I have used random forest classifier model. Use fair learn metric frame to analyze model performance across location groups. Use SAP to explain prediction for class Valdica. Interpretation is to whether the model is fair with respect to location and which feature drive prediction for Valdica. Okay, so firstly I have run my instance, open the Jupyter Lab, created week 9 Python notebook, and then install the requirement library, Fairlearn, SAP and IP widgets, and then import the libraries and load the Irish datasets. Then here I am using the classic Irish datasets. I have added a new column called location. It says synthetic sensitive attribute with values 0 and 1 assigned randomly. The label column is renamed as to species with classes 0 is equals to Setosa, 1 is equals to versicolor and 2 is equals to Virginica. I will use location later as a sensitive feature for fairness analysis. And here you can see the dataset, and next I have split the data into train and test sets and train a random forest classifier on all five features including location. On the test set, overall 91% accuracy is present, and the confusion matrix shows that Setosa is classified perfectly and Versicolor and Virginica have a few misclassification, as you can see. The classification report confirms that this precision and recall are around 0.8 and 1, which means the model is performing reasonably well on all three classes. Now here we can see the fairness learn metric frame, and we have used the fair learn metric frame to analyze fairness with respect to the location attributes. All the accuracy is about 91%, which matches the previous result. When I break it down the location, for location 0, the accuracy is 90.5%, and for location 1 accuracy is 91.7%. And so the model performed very similarly for both groups. There no big accuracy gap, which is a good sign from the fairness perspective. The selection rate is slightly higher for location 1 and then for location 0. That means the model predicts the positive classes a little more often for group 1, but the difference is small here. Okay, now I have computed the SAP values for the model, focusing on the probability of the Virginica class. Now in this I have used the SAP full data set for the Virginica class, and I have plotted the dot graph for the Virginica class. Here you can see each dot here is one test sample. The color represents the actual feature. Red means high value, as you can see. Blue means low value. The position on the x-axis is the SAP values, which tells us how much the feature pushes the predictions towards or away from the Virginica. We see that petal width and petal length are on the top with the largest spread of SAP values. That means they are most important features for predicting Virginica. And red points on the right of the petal width and petal length means that the large petal width and length strongly increases the probability of Virginica. And blue point on the left means that small petal width length push the prediction away from Virginica. And sepal length and sepal width have a much smaller impact. The location feature is almost centered around 0, which means it has very little influence on Virginica prediction. It is a good from a fairness point of view because the sensitive attribute is not driving the prediction. Now here is the bar plot. This bar plot shows the average absolute SAP value for each feature. Again, the Virginica class, it summarizes which features are globally most important. As you can see, petal width has the highest average SAP value, so it is a single most important feature for predictive Virginica. Next come petal length. Sepal length and sepal width are less important, and finally location has very small mark, confirming that the synthetic sensitive feature has almost no effect on the Virginica production. So I have also added the observation in my PPT. As you can see, the petal width and petal length show the largest spread of subvalues, and for the graph also. Now the conclusion of the week 9 is to add a location as a random sensitive attribute, train a random forest model or 5 feature, perform fairness analysis using fairness learned metric frame, generated and interpreted SAP plot for class Virginica. Fairness insight is that accuracy and selection rate are similar across location group, though strong evidence of unfair behavior toward a specific location group. As explainable, insight is petal width and petal length are the dominant drivers of Virginica prediction. Location has negligible SAP impact. The model is not relying on the sensitive attribute. That's all from my side for week 9.